Hey guys, how's everybody doing? I hope everyone's doing well throughout all this. I know Musa has been dying. He's way too social, according to him, to be locked up at home like this, but we're all trying to get through this. Anyway, my name's Keith the Merchant, and today I'm going to be talking to you about the effects of solar farm installation on density and activity of Pogonomyrmex species, otherwise known as harvester ants. So, renewable energy has been on the rise since about 1965 worldwide, and I expect to see it to continue to increase. So, if we look here, this is a graph that represents the modern renewable energy consumption around the world. And as I said, around 1965, we started to see a very steady incline with a boom in the mid 2000s. And since then, it's been rising consistently. So let's step back a little bit. Let's talk about impact surveys. Before any construction project or anything similar, an ecological impact survey must take place. So this is anything from a solar farm going up, a new business, apartments, anything like that. Anytime you're going to be taking a plot of land that's not already developed, somebody has to do a survey to see what this is going to do to the ecosystem. And in other studies, such as one done in Spain, researchers performed an impact survey comparing the ecosystem where a solar farm had been for, I don't know how long, actually the paper didn't tell me, but it had been there long enough for the native flora and fauna to rejuvenate after the solar farm was installed. And they compared that to a nearby field that has not been developed in any way, and they were just looking at the differences in diversities, abundance, etc. In this study, they used indicator species such as butterflies and bees. And for those of you guys who don't know, an indicator species is a species in these surveys that they use to say this animal is doing good, this plant is doing good, therefore everything must be doing good. They're using it to speak for the system as a whole. And one theory as to why we saw an increase in biodiversity and density in the solar farm, that's what they saw in Spain, was that where the solar farm was, there was actually more diversity. And the reason they believe this was because the slight shade provided by the solar farms allowed for more plants to pop up. And with the plants, the flowers being there, the pollinators came in. And, with the shade and the water retention, the sun not beating down directly on the plants, that's why we're seeing this. So this relates to my project because harvester ants can be temperature sensitive. They're known to be most active at 25 to 30 degrees Celsius. The solar farm that I was intending to look at is going to be put up on the CSU Pueblo campus. I'm sure a lot of you guys know about it. And the summer temperatures there can average 31 to 34 degrees Celsius. With the shade cast by the solar panels, the average ground temperature would be lower, increasing the ant activity. In theory, that's what I'm expecting to see here. So why is this important? Well, why are ants important? The harvester ant disperses seeds throughout their habitat. This is an important ecological role. A lot of plants rely solely on this. For instance, annual plants are seen to be more commonly dispersed than perennials. So just a quick plant lesson here. Perennials come back every year. They'll die out in the winter and they pop right back up come spring. Annuals don't do that. They're a one and done deal. So the ants dispersing these annual plants may give these annuals a chance that they might not have had otherwise. And we know that harvester ants perform a large percentage of seed dispersal in desert habitats, but we have not seen exactly what they do in the shortgrass prairie systems, which is the type of environment where the solar farm will be going up on campus. We also know that harvester ants have been known to have positive interactions with other granivores, such as mice. So normally when you see two different animals, different species, that use the same resources, more often than not, you'll see competition. However, here we're seeing positive interactions between the mice and the ants. Along with promoting biodiversity, harvester ants provide other beneficial functions to the ecosystem. Some of these functions include soil aeration. Aeration can be beneficial for plant growth by mixing of nutrients at different depths. Any of you guys who have been to a well-maintained park or a golf course or something, you see those little plugs of grass that are a couple inches long that pulled out of the ground. That's soil aeration in order to help the lawns. The ants do that naturally, and It's actually really cool in the research for this project. I learned that per mature harvester ant colony, they pull about 6 to 7 pounds of soil out of the ground to form their mound. And so in a well populated field of harvester ants, we're looking at 200 some pounds of variation. That's way more than these golf courses are seeing. And I just thought that was pretty nuts. So furthermore, ants remove plants around their mound, and this mound, or the area around the mound, is known as the disc. This can be a positive or negative thing depending how you're looking at it. On one side, you have the removal of these plants can allow for seed dispersal. You know, they're cutting them down, they're shaking them up. This can shake seeds loose that normally wouldn't be shaken loose and allow those plants to regrow slightly away from the mound. On the other side, the ants are still killing plants, yes, but you've all seen an ant mound, you know, the bare area around the actual ant hill, that's the disc, and that's not a lot of plants getting killed on the grand scope, you know, the big scope of the whole field. We've seen harvester ants have increased biodiversity in deserts and interact with other granivores in the shortgrass prairie system. So we see a little bit what they're doing in the desert. We see a little bit what we're doing in the shortgrass prairie, but we don't know all of what they're going to be doing in the shortgrass prairie system. And that's part of what I'm looking to find out here. We have seen that there's a wider range of harvester ant species in the shortgrass prairies in presence of prairie dogs than without prairie dogs. I thought this was neat. The sea-based students in the wildlife field do a lot of work with prairie dogs and their importance to the ecosystem, and I just thought it was really cool. In this paper here, they found in fields without prairie dogs and no even abandoned colonies, they were finding one, maybe two species of harvester ant versus where there were prairie dogs, they were finding 3, 4, 5 different species all interacting with each other, all just different harvester ants. So my hypothesis in all this is that the installment of the solar farm in the shortgrass prairie will have a positive effect on the activity and density of harvester ant species, meaning there'll be more colonies per area of land, and those colonies will be harvesting more and, most importantly, distributing more seeds. So my specific aims for this study are to quantify the activity of harvester ants before and after solar farm installation, measure the density of harvester ants before and after the solar farm installation, and measure the density of plants commonly dispersed by the harvester ants before and after installation. So how I plan to do that, the plot where the solar farm is to be installed on TSU property will have transects measured out and walked before the installation of the farm. For those of you who don't know, a transect is a straight line through an area of land used to record data about species of plant, animal, or otherwise that occur in that area. The solar farm will be placed on a 22-acre plot. For the sake of even measurement, we will extend our area just outside the reach of the solar panels themselves to make it an even 9 hectares. I'm going with the metric system here. For me, it's a lot easier to do the research. A hectare is a 100 by 100 meter plot. So for each hectare, we'll have 50-meter transect in the center of the plot, leaving 25 meters to either end of the transect. Data will be recorded every 10 meters along the transect and 5 meters out to either side of the transect. So trust me, I know looking all that in words is really confusing. So I try to make you guys some charts or graphs here to see exactly what my transects will look like, how they'll be measured, etc. So I'll let you look at that for just a moment. Here on the left, we have the total area of the solar farm, the 9 hectares I mentioned previously. That's everywhere where the solar farm is going to be and a little bit outside of the range. To the right is the actual transects I'm going to be walking per square. So what exactly will be recorded? Specifically for my specific aim 1, both active and inactive mounds will be recorded. A mound that can remain noticeably visible for 8 years after being inactive. So to determine the status of the mound, will have to be checked for workers outside the mound on multiple occasions. So what I'm talking about there is an inactive mound is a colony, you know, the mound is there, but the ants are no longer living there. The queen died, they moved, whatever the case is, they're not there anymore. I'm going to have to take several trips to the field in order to record all this data. If I find a mound believed to be inactive, I'll check up on it regularly. Also, if I notice an active mound is no longer active, again, the queen could have moved, died, etc., that'll be recorded as well. From here, I will record the level of activity per colony. This will be determined to the number of workers on the mound as well as workers forming highways off the nest to harvest. So again, you've all seen anthills, you know what they look like. Sometimes you'll see one or two ants outside. Sometimes the whole thing is swarming with them. That's definitely data that's going to be recorded, as well as how many trails I could count going off the mound to gather food. Highways might be a little tough. In harvester ants, they don't form super highways such as you'll see in fire ants or army ants, your more tropical species. Some ants only take multiple trips, and actually not all ants harvest, actually a small percentage do. So again, just going to be a lot of careful recording throughout multiple trips to the field. Measuring density, this is going to be a lot easier. The amount of colonies per area will be the density. The same transect size and locations will be used before and after the installation to keep it consistent. And seeds being dispersed, this is going to be a little bit tricky, but not at all impossible. Seeds found on the mounds or being carried by ants will be taken and germinated for the plant to be identified. Yes, I have absolutely no problem jacking an ant's food from him just so I can find out what's going on. This can be time consuming without knowing the plant the seed comes from. It's impossible to really know without germinating it. And the germination period will be unknown, being we don't know what the plant is. However, I will germinate them actually at the CSU Pueblo greenhouse, allow them to grow, be identified, and this will really help with data for exactly what plants these ants are helping get moved around the shortgrass prairie. So the time frame for this whole study, performing the initial survey before installment will be pretty quick and easy. However, to properly measure the density and activity of harvester ants before the installment, we would have to wait for some of the natural habitat to regenerate. When a solar farm is put up, it becomes just a barren dirt lot. You know, they bulldoze it, everything like that. It's just dirt. And how long it'll take for the plants, animals to come back to this area could be 20 to 25 years. It could be a lot shorter. I know the school has plans to seed native plants in the area after the installment, so it could be quicker. And it will be checked up on regularly. As soon as I feel that we can come back and measure this data post installment, it'll happen. In summary, we're not completely in the dark about harvester ants and their role in and their effects in the environment. However, we do not know how far solar farm affects the essential members of these biocommunities. With solar farms and other renewable energy on the rise, to me, it's really important that we be on the forefront of understanding the biological impacts of these coming energy sources. If we don't know what they're going to do to their environment, we can't say that they're good or bad. So I think it's important we start learning about all aspects and not just your charismatic megafauna, not just your deer, not just even your prairie dogs. I think it's important we look at these ants and other invertebrates because they hold such key jobs in these systems. I just want to thank you guys for taking time, sitting down on your couch in your underwear and listening to my presentation. Feel free to comment any questions and I'll do my best to get back to you guys. And here are some citations for you.